Got a big morning here at Diverse Dimensions. We're in the lab today. We've got some students coming in with their gold arms, and we're going to do some measurement on this sheet metal here, this assembly. But yeah, big day today with this older piece of equipment. And I can remember the day we pulled this out of the box, man. It felt like Christmas morning. Just a great measurement device. And now we've got the level of quantum as well, and some platinum arms and some laser scanners. So plenty of good measurement equipment to use to capture data and to do inspection with. But truly, the gold and silver series arms, great pieces of equipment. And what I'd like to show you guys, though, before I get into training my students, is how to calibrate the probe so you can get off and running and start to measure and have confidence that you're actually calibrated and the measurement numbers that you're getting are accurate. So great piece of equipment, too, and I just can't stress enough to be on Faro's warranty plan. We always recommend that to every student. We've got multiple arms and multiple seats of software and multiple scanners, so we always recommend staying on the warranty plan. It's so beneficial. So it costs a little bit of money throughout the year, but I can't understand not doing it. It's such an important part of what I do for Diverse Dimensions. So we're going to jump into that today. Somehow I got my dog running around here trying to bury a bone in my hardwood floor someplace, so that should be kind of entertaining as well. So jump into the SAT file with me. I've pulled up my old tough book here, so I've got communication with the gold arm. And I'm going to change the view a little bit. We're going to come in at a different angle, because the first thing I recommend when we calibrate the gold arms or silver arms, it's a sphere calibration with a 1-inch sphere that is actually it's fixed on the body of the arm. So a little bit different than what we do with the quantums and the platinum arms. So I want to show you that. So we're going to get a little different camera view here, but the first thing I want to say is when you put your arm on your table or on your tripod or wherever you're mounting your arm, make sure that sphere is accessible. We're going to be getting all around that sphere in different orientations, and to have that sphere just out there in space, that's the best way that will capture the points on it. So jump into the SAT file with me here, and let's see how we can make this thing sing. All right. Well, what I'm going to do first is I'm just going to run right over here to my Devices menu, and then I'm going to go to Probes, just like in the other style arms as well. Once I click on Probes, notice this dialog box. So this dialog box looks a little bit different than what we saw with the other style arms. The first thing, though, just like with the platinums and whatever other newer style arms, go right to the diameter of the probe first. Always make sure that you've got the right size diameter probe in. I'm using a 250 right now, or this 1/4 inch. And again, just like the other probes too, right on the side of these probes, it's going to be written what the size is. Like right here, I've got 250 written right there. So just make sure that you've got the right size probe in that diameter box before you start to calibrate up. Now what I'll do here is I'm going to run over to this 1-inch ball icon right here. Once I click on that, notice this dialog box that comes up. This is very useful. I've got a picture or a diagram that shows where I'm going to be taking my points on the sphere, and it shows the handle orientation as well. And notice I've got points that I'm going to be putting around this equator of this sphere first, and it looks like I'm starting here at 12 o'clock. So keep an eye on that part of the screen as well as what I'm going to be doing here on the video too. So I always take the arm, and I just counterbalance it out, let the thing rest right down here, and then I can hold onto the arm with one hand here as well, just that little trigger area. Now what I'm going to do is just kind of follow the picture. I'm going to be starting at 12 o'clock with my first point. And the way I'm going to do this is I'm going to take one point with a green, and then I'm going to compensate with the red. And then the next position here, green and then red. And I'll work my way around, green and red. Green on the sphere, compensate away. And now here's number 5, green and then red. Now notice again up at the top or on this dialog box in the picture, Looks like I'm back up on the top of the equator, and notice that the handle orientation has changed now. So what I need to do is I need to rotate the handle around and then over this way. Now I'm going to take another series of those 5 points. So I'll start up top, and I'll keep working my way around. I always find it very useful to just stabilize the probe as I'm on the sphere here. Not putting much pressure on it, just a little bit. And then here's the 5th point. Okay, so there's my first 10 points. Now, notice the diagram again. It looks like I'm going to be taking some points here that are going to be east to west. So notice the red dot is way on the right-hand side of the sphere, and the handle orientation wasn't flipped from the last way. So I'm going to take my first point here, then compensate away, and then just grab the arm and have it point directly to the center of the sphere. I'm going to put 5 on there, and I'm pointing directly into the sphere again. Green and then red. And now here's the 5th point. Green and red. Now I've got 4 points, it looks like, from east to west, but this time I've got a flip of the handle. So I'm going to bring it back down, rotate it in, and I'll shoot 4 points around the equator, east to west. There's 1. There's 2. There's 3. And now here's 4. It might be tough to see. I'm blocking that. But there's 4. Now, no handle flip here. It looks like I'm taking 4 points starting at the top, and I'm going to the bottom. So I'm going north to south. And again, I'm going to be pointing directly to the center if I can. There's 1. And there's 2. There's 3, and then all underneath there, there's 4. Now I've got another 4, it looks like, from north to south, but I've got a handle flip that just occurred. So I'll do this again. Take 4 from top to bottom. And again, I'd like to just stress, too, it's so easy when you can have this sphere accessible out here where I'm standing. Instead of it being on this back side, this would just be impossible to try and get the arm back there to do that calibration. So always set up, if you can, with the probe or with the sphere facing you, out where you're standing. Now I'm ready for the 2nd point here, north to south. Here's number 3. And then 4 underneath. There, now I've taken 27 points, and then Faro goes out, and it solves for the best fit center of that sphere. And what it does is it samples all of those 27 points, and it gives me the calibration error. Notice that I've got 1.4 thou of deviation or of calibration error. Well, that's pretty good. I can measure and I can feel confident that my measurement is within that 1.4 thou error. So, but I can't stress enough, just getting good at doing this calibration. It does take some time to remember the sequence, how to go through those 27 points. But if you need to, go check out the video again and watch that sequence, or keep an eye on the dialog box that shows the diagram of the order or of the sequence that you'll be taking these points. So never be afraid to try swapping out probes midstream in a measurement session either. It just takes a little bit more time to calibrate with the gold or the silver series arms than it does with the newer styles. But just don't be afraid of that. It's always good practice to do that at the beginning of every measurement session. And if you don't take the probe in and out, you don't need to calibrate again. But we always like to say, try that a few times and just get good at it and get comfortable with it.